Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on trigonometry degree level chapter hyperbolic functions, lecture number 5, in which I will solve some more problems on hyperbolic functions. Now we solve a problem. Problem is, if sin theta plus I phi equal to x plus iy, then prove that number 1, x square by sin square theta minus y square by cos square theta equal to 1. Number 2, x square by cos hyperbolic square phi plus y square by sin hyperbolic square phi equal to 1. Now we solve this. Solution. Since given that sin theta plus I phi equal to x plus iy implies that this is sin theta cos I phi plus cos theta sin I phi, this equal to x plus iy, implies that sin theta cos I phi is hyperbolic cosine phi cos h phi plus cos theta, this is I hyperbolic sin phi sin h phi, this is equal to x plus iy. This is number 1. Equating real and imaginary parts of both sides, we get x equal to sin theta cos h phi, y equal to cos theta sin h phi. This is number 2. This is number 3. Implies that x by sin theta, here x by sin theta equal to cos hyperbolic phi cos h phi, and y by cos theta equal to sin h phi. This is number 4. This is number 5. Using 4 and 5, we get x by sin theta whole square minus y by cos theta whole square equal to cos h square phi minus sin h square phi, implies that this is x square by sin square theta minus y square by cos square theta, and value of this is 1. We know from the formula of hyperbolic function cos h square phi minus sin h square phi equal to 1. So first part proved. From 2 and 3, we get x by cos h phi, this is x by cos h phi equal to sin theta, and y by sine h phi equal to cos theta. This is number 6, this is number 7, this is number 8. Using 7 and 8, we get x by cos h phi whole square plus y by sine h phi whole square equal to sine square theta plus cos square theta, implies that x square by cos h square phi plus y square by sine h square phi, and right side is 1. Sine square theta plus cos square theta is 1. So second part proved. Now we solve the next problem. Next problem is if sine theta plus I phi equal to u plus iv, then prove that sine square theta and cos h square phi are the roots of the equation t square minus t multiply 1 plus u square plus v square plus u square equal to 0. Now we solve this. Since t square minus t multiply 1 plus u square plus v square plus u square equal to 0 is a quadratic equation for the variable t. Let alpha and beta are roots of this equation. Let this equation is number 1. Therefore, alpha plus beta equal to minus b. b is minus 1 plus u square plus v square minus b by a. a is 1. So this is 1 plus u square plus v square. This is number 2. Alpha beta. c by a. c is u square. u square. a is 1. u square. This is number 3. Since given that sine theta plus I phi equal to u plus iv, implies that formula of this sine theta cos I phi plus cos theta sin I phi equal to u plus iv, implies that sin theta cos I phi is cos h phi plus cos theta sin I phi is I sin h phi u plus iv, right side. This is number 4. Equating real and imaginary parts of both sides of 4, we get u equal to sine theta cos h phi. V equal to cos theta sine h phi implies that u square equal to sine square theta cos h square phi. V square equal to cos square theta sine h square phi. This is number 5. This is number 6. U square plus v square equal to sine square theta cos h square phi plus cos square theta sine h square phi. This equal to 1 minus cos square theta. Sine square theta equal to 1 minus cos square theta. Cos h square phi is 1 plus sine h square phi plus cos square theta sine h square phi, and this will be equal to, we multiply this bracket by 1 plus sine h square phi. Now multiply by minus cos square theta, minus cos square theta minus cos square theta sine h square phi plus cos square theta sine h square phi. This and this cancel. This equal to sine h square phi. 1 minus cos square theta is sine square theta, and sine h square phi is cos h square phi minus 1 plus sine square theta, implies that u square plus v square plus 1 equal to sine square theta plus cos h square phi, implies that this u square plus v square plus 1 equal to alpha plus beta. Alpha plus beta equal to sine square theta plus cos h square phi. This is number 7. From 3 and 5 we get, in 3 alpha multiply beta, alpha beta equal to u square, and here in 5 u square is sine square theta cos h square phi. This is number 8. From 7 and 8 we get, in 7 alpha plus beta is sine square theta plus cos h square phi, and in 8 alpha multiply beta equal to sine square theta multiply cos h square phi. We get alpha equal to sine square theta, beta equal to cos h square phi. Therefore sine square theta and cos h square phi are roots of the given equation. Proved. Now we solve the next problem. Next problem is if sine alpha plus I beta equal to cos A plus I sin A, then prove that cos square alpha equal to sine hyperbolic square beta. Now we solve this. Solution: given that sine alpha plus I beta equal to cos A plus I sin A, we use the formula sine A plus B and we get this, and right side same. Here cos I beta means cos hyperbolic beta and sine I beta means I sine hyperbolic beta. Now equating real and imaginary parts of both sides, cos A equal to this and sine A equal to this, cos alpha sine hyperbolic beta. This is number 2, this is number 3. Now squaring 2 and 3 and then adding cos square A plus sine square A equal to this square plus this square, right side, and left side is 1, cos square A plus sine square A equal to 1, and in right side sine square alpha equal to 1 minus cos square alpha, and cos hyperbolic square beta equal to 1 plus sine hyperbolic square beta, and this term remain same. Now here we write right side to left side. Here we multiply by 1 multiply 1 plus sine hyperbolic square beta, the same, and now we multiply this bracket by minus cos square alpha. We get minus cos square alpha minus cos square alpha sine hyperbolic square beta, and last term be same, and we write left side 1 to right side 1. Here this is negative, this is positive, cancel, 1 left side 1 right side, cancel, implies that sine hyperbolic square beta equal to cos square alpha, implies that cos square alpha equal to sine hyperbolic square beta. Proved. Next problem is if sine theta plus I phi equal to tan alpha plus I sec alpha, then prove that cos 2 theta multiply cos hyperbolic 2 phi equal to 3. Now we solve this. Given that sine theta plus I phi equal to tan alpha plus I sec alpha, now we use the formula sine A plus B. Here we get this expansion, right side same. Here cos I phi is cos hyperbolic phi. Here sine I phi is I sine hyperbolic phi. Now equating real and imaginary parts of both sides of 1. Here tan alpha equal to sine cos hyperbolic phi and sec alpha equal to cos theta sine hyperbolic phi. Now squaring 2 and 3, then subtract square of 2 from square of 3, sec square alpha minus tan square alpha equal to this square minus this square. Here we use the formula cos square theta. For cos square theta we get 1 plus cos 2 theta by 2, and for sine square theta 1 minus cos 2 theta by 2, and we take common half. Now we multiply this bracket by sine hyperbolic square phi, and we multiply this bracket by cos hyperbolic square phi, and we get this value. Now we take common cos 2 theta, remains cos hyperbolic square phi plus sine hyperbolic square phi. Now we take common minus cos hyperbolic square phi. here minus sine hyperbolic square phi. Now we send 2 to right side. 2 multiply 1 equal to 2. Cos 2 theta, and value of this formula is cos hyperbolic 2 phi, and formula of this cos hyperbolic square phi minus sine hyperbolic square phi is 1. We write here 1. We send minus 1 to this side. This will become 3. And left side cos 2 theta cos hyperbolic 2 phi, and right side 3. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.